Hey everyone, we're going to do notebook page 16, memory and forgetting. So if you want to take down the title card now, you can do so. All right, let's go ahead and get started. We'll start with short-term memory, and we're going to talk about short-term memory and long-term memory. And while they're separate, short-term and long-term are separate functions. All memories are temporarily stored as short-term, and some of the information is encoded and stored as long-term memory. So short-term memory itself is activated memory that holds a few items very briefly. So, we can remember 7 digits of a phone number briefly when entering a contact into our phone, but the information is soon stored or forgotten shortly after entering it. So short-term memory can be divided into 3 types: sensory, iconic, and echoic. With the last 2 being specific to visual and sound, respectively. Now, sensory memory, very immediate, so very brief recording of sensory information into the memory system. Maybe a half a second, you'll remember, touching something and how it felt, and every sense, every kind of feel, temperature, everything that happens around you. So sensory memory generally is touch, taste, smell. So a scent can be recalled immediately after encountering the smell, but if asked an hour or a day later, you would likely not remember it. Take on the slide. We'll move on to slide 2. Iconic memory is the momentary sensory memory of visual stimuli. So a picture image memory lasting no more than a few seconds. So for example, if you're shown an image for a few seconds, you can recall and recreate the details for a short time, but as seconds go by, the detail and accuracy will diminish. Lastly, echoic memory is the momentary sensory memory of auditory stimuli. So echoic memory occurs even if attention is elsewhere. Even if you're paying attention to something else, you still can hear those sounds and words seem to echo in our heads for about 3 to 5 seconds. So for example, if the teacher feels like you aren't paying attention and asks, "What did I just say?" you can actually think and recall the words that said from a few seconds ago, even if you weren't paying attention. It is in your short-term memory. So those are those types. Slide here. Now let's move on to slide 3 and talk about long-term memory. Long-term memory is the relatively permanent and limitless storehouse of the memory system. It's located primarily in the cerebral cortex. Long-term memory includes our knowledge, skills, and experiences. So with millions of different combinations of neurons in the brain, there is near limitless capacity to learn, as no human could permanently fill all neurons in a lifetime. It just won't happen. So there's some different types of long-term memory. One type that has substantial staying power is procedural memory, which is memory involving an automatic motor movement. So a procedural memory would be like riding a bike. Once you learn, you don't often forget how to use that skill even after extended periods of use. It might be how to play a specific video game. Might be how to crochet or knit. Those things that maybe if you have to pick it up a year, 2 years, 3 years later, it might take you a little bit to get it back, right? But you will. That's a long-term memory. Additionally, we have sometimes the long-lasting, very clear memories known as flashbulb moments. These are vivid memories of an often emotionally significant moment or event that kind of get implanted in that long-term memory. I'm going to write this down. We'll move on to long-term potentiation. The reason flashbulb moments are believed to be so clear and long-lasting is due to a phenomenon known as long-term potentiation. It's an increase in neuron firing potential after a brief, rapid stimulation. So what this means is that when a particular memory is coupled with a surge of neural or emotional activity, surge of dopamine, surge of serotonin, because something's very embarrassing or very scary or it makes you very happy, then we seem to recall that memory with better detail, accuracy, and more vivid imagery. In fact, the stronger emotional or neurological surge between neurons when forming a memory, the stronger the memory tends to be. So this theory of long-term potentiation and emotions being linked to memory has been confirmed in lab tests on patients using drugs that block long-term potentiation. So patients with their long-term potentiation processes blocked experience reduced memory speed and efficiency. So emotional arousal can sear certain events into our memories and inhibit neural memories at the same time. For example, our memory prioritizes those particularly emotional moments and dismisses ones that are kind of neutral. So it might also, if you don't have the emotional moment, you might lose that memory. For example, you may not remember your grades for fourth grade, but you can certainly remember maybe the first breakup, first love, your first kiss, a close relative passed away, something that was more emotional. These flashbulb moments can even be societal-wide, something like 9/11 or Pearl Harbor. Those moments that are kind of big moments that have that long-term potentiation. There's good evolutionary evidence for this process, as the prioritizing of emotionally arousing events often results in us remembering traumatizing, dangerous, or exceedingly successful moments so we can either avoid them in the future or to replicate them in the future. Let me put up the slide now. Let's move on to slide 5, long-term aids. So while long-term potentiation certainly strengthens memories by forming strong, surging neuron connections, several other factors influence our ability to retain information in the long term. Retrieval cues, for example, are other bits of spatial information that help recall memories from a web of neurons. So for example, when learning the names of new people in a classroom, we often are able to better recall their names when we think about where they sit. Additionally, mood congruency is the tendency to recall memories that are consistent with one's current mood can help us recall memories. So if someone's angry at their significant other, they're often reminded of other times they were angry at their significant other. These memories are more readily available when in the same mood. When remembering lists or sequences, the serial position effect takes place. It's the tendency to remember the names or information at the beginning or the end of a list. Can impact which terms we remember more accurately. Stereotyping can hurt memory and remembering as well. So these are all included here. Let me put this slide up and then we'll keep talking about this. You're going to take us down. We'll move on to the next slide. So there are also a series of strategies one can use to aid the explicit processing of memories. So chunking is the organizing of information to familiar, manageable units. So for example, learning history in historical eras or psychology in specific fields will help us remember the information. Mnemonic devices, memory aids like acronyms and other tricks used to remember information. For example, learning colors of the rainbow. The acronym ROY-G-BIV can be helpful, remembering red, orange, yellow, green, etc. 3, the spacing effect. The spacing of learning and relearning information across several days or weeks rather than cramming it all in one time. So studying and reviewing a little each day will actually help you remember more for the AP test than cramming the night or two before. The testing effect, or self-testing recall, has been shown to be more effective than rereading or cramming. So something like using flashcards would be an example of the testing effect, right? You kind of self-test yourself, and that's better than just cramming everything and reading it again. Additionally, forming and learning in the form of a hierarchy aids memory retention. So we humans have kind of a long-developed neurological systems perception for hierarchy, with evidence dating back more than 320 million years, long before dinosaurs, regarding our perception and cognizance of hierarchy. So, for example, Jordan Peterson came to fame by connecting the neurological functioning of serotonin levels and their impact on lobsters. Simply by adding serotonin, neurotransmitter with low levels linked to depression, to male lobsters, the lobsters were far more willing to fight for position in the lobster hierarchy after losing a dominance battle or in spite of a history of defeat to a particular male. What his interpretational study showed was that neurological roots for our awareness and physiology has been linked to hierarchy for hundreds of millions of years. So we're predisposing us to see, interpret, and remember things more readily in hierarchies what's at the top, what's at the bottom, what's in power, what's not in power. So that will really help. Lastly, obtaining adequate sleep has been shown to profoundly improve one's memory and other cognitive functions, as shown in the memory and cognitive performance of control groups deprived of sleep versus experimental groups with normal sleep. Regardless of the method, long-term memory is difficult to form and maintain it. As shown in the work of Hermann Ebbinghaus, who pioneered research regarding relearning and analyzed memory data for patients, most information tends to drop off quickly, leaving one with less than 25% of their originally learned knowledge after a month's time. These results can be seen on the Ebbinghaus forgetting curve, which I'll put up after this slide. So let me go and put up the information here. Write this down. So here's the Ebbinghaus forgetting curve, right, of when you learn something, what's your retention rate like over time? You can immediately recall it, obviously. But after 20 minutes, it drops by almost 40%, by over 40%. And as time goes on, you see that drop off. That's the forgetting curve. You're going to forget information over time, and that's fine. That's normal. But obviously, our goal is trying to retain this information. Could be helpful. So let's talk about amnesia. There may also be biological factors that impact our encoding, storage, and retrieval processes. Anterograde amnesia, for example, is the condition in which patients fail to develop new memories, while retrograde amnesia, on the other hand, is the failure to retrieve old information from one's past. There's two different types. So anterograde, right, is when you can't develop these new memories, whereas retrograde, you're forgetting things from the past. Aside from potential biological causes of forgetting, the presence of other memories can impact the encoding and retrieval process. So proactive interference, for example, is the disruptive effect of prior learning on the recall of new information. This is why it might be hard to make a new password for one's phone, as the memory of the old password kind of inhibits the encoding or retrieval of the new password. Another example might be accidentally calling your new boyfriend or girlfriend by your old boyfriend or girlfriend's name. That's human. That's normal. Conversely, retroactive interference occurs when new learning disrupts the recall of old information. So one example of retroactive interference is when the song you're currently listening to or just listened to actively prevents you from remembering the words or melody of an older song. Another example might be accidentally calling your, like I said, calling someone by the wrong name in a similar role. Sometimes I have a sibling in class, and I connect them with their older sibling, right? Because I remember that name instead of the new one. So that can happen as well. Right. And last one will be memory errors. There are also several factors that can lead to recall and retrieval distortions. The misinformation effect, the incorporating of misleading information into one's memory of an account, can cause one to distort or misremember certain details. Elizabeth Loftus, pictured here, pioneered research on the misinformation effect by working with eyewitness accounts in the legal system. Loftus successfully showed that simply rewording questions alter the recollection of witnesses. For example, we've talked about in class, by using the word smashed as opposed to hit or bumped when referring to a car accident, witnesses consistently recalled broken glass and fire when the accident contained neither. Additionally, source amnesia is attributing an event or memory to the wrong source. This occurs when our brains fail to retrieve a memory. Our brains are experts at rationalizing errors, so we often attribute what we are seeing or hearing in the moment as the memory that we fail to retrieve. This is often associated with deja vu, as we're not actually seeing the same scene twice, we're merely experiencing the rationalization for our retrieval failure. So we'll get more into some of these, or we already have, perhaps, on how this works. So let me put up this slide, and then this is the last one. You take this down, then you're done with this notebook page. Thank you so much. I definitely appreciate it.